Hi, today we're going to look a bit more at simultaneous equations and we're going to focus on equations like I've got on the top right. So I've set this as a question previously and it is a trickier one to deal with the method I gave, but I am going to show you why we can still solve equations in the method I gave, but I'm going to give a second method. Now, why study two methods? Why not just stick with one? Well, maths is not always about just learning a fixed method and always going with it. It's about having understanding of why different things work and why maybe one might be better somewhere, the other one might be better somewhere else. It develops your understanding, it makes you become a better problem solver. So that is the thinking behind it. I actually think I'm coming around to preferring the method that I basically taught you last lesson, but you'll find that it's commonly taught in a different way. Anyway, we're going to get on with it now. So in front of me, I've got a set of scales. I've got two cherries and I've got a peach, and then they must together weigh 300 grams. Now, I don't know how much a peach weighs and how much a cherry weighs, and there's no way of knowing from this set of scales because if I take one off, it's just going to be unbalanced, and we can't really measure how unbalanced it is. That would be great if I could take the peach off and know what was on the right hand side. Then I could work out the cherries because there's two of them. I could assume they're the same weight. But as things stand, this actually has an infinite number of solutions. It could be that they all weigh 100. It could be that the peach weighs 200 and the cherries weigh 50 each. There's just lots of possibilities. So this is why we need a second sort of situation or equation to give us the knowledge we need. Now we can write down a mathematical equation for this. I think before I do that, I'm going to just talk through. No, I'm going to write down the mathematical equation I've decided. So I could say that the weight of a cherry is C, and I'm going to say they're identical, these two cherries. So this would be 2C, and then I'd add on the weight of the peach, which I'm going to call P, and that is going to equal 300. It's equal because the scales are balanced. And then on the left hand side, I've got the cherry, and then I've got a peach, and then that's equal to 250. Now this is not that dissimilar to what we saw last lesson, so I'm going to first of all talk about this method. Basically, it's loosely called substitution actually, and it's basically to make P the subject of both of these equations. So P is going to equal 300 minus C over here, minus 2C, sorry, apologies, 300 minus 2C. All I've done is rearrange this. It's hard to talk about it from a weighing scales point of view because it's like I've taken them off here, so I'm going to have to take them off here, but I can't take two cherries off of that weight. But like I can imagine taking the weight off, that's what's going on. And then if I do the same over here, it's going to be P equals 250 minus C. So I've made P the subject of both. It must be that the peach is the same weight in both situations, like I'm assuming that. So I can set them equal to one another. That's what we did before. And I've created an equation. I can then solve this equation. I could add C to both sides. That's probably what add 2C to both sides. So it becomes 300 equals 250 plus C, because I'd add 2C to minus C, that'll give me a plus C. I can then minus 250, and I'm going to get that C is equal to 50. And from that, I can see that the peach, I can substitute back in. That's what we did before. We can substitute either into that one or into that one. Actually, we could substitute into these as well. It doesn't actually matter. But we see that we get 200 because I know that 50 plus 200 is 250. I can check it here. 2 times 50 is 100, so I'm going to need 200 there. So that is the solution, and that is using what we did before. So this method works remarkably well actually, and you are more than welcome to use it. I am, however, going to show you a second method which you may prefer, and it is it's quite often commonly referred to and taught actually instead of the substitution method. And sometimes it has its advantages, it can be quicker, so we'll see. Okay, I've got my two equations, and actually this time I'm gonna write c plus b equals 250 below the first equation. Now, what I can imagine doing is I know these sets of scales are equal, so if I took the same amount off of this one and this one, it would stay equal. But I know that these are the same amount, so I can imagine taking off a peach and a cherry, and to keep it balanced, I'm then going to have to take off 250 grams. So I'm going to be left with 50 grams. Okay, I'm just going to do that again, just to be try and be really clear. So I know that these two weigh the same. So if I take a peach and a cherry off of here, I can take the same amount. I can take 250 off of here, and that leaves me that a cherry equals 50. And if I've got that a cherry equals 50, I can very quickly get that the peach is 200, and I'm done. Okay, the way you would do this algebraically would be basically to subtract these equations. So I'm going to subtract the left-hand sides, and I'm going to subtract the right-hand sides. Notice I'm subtracting all of it. Okay, this is sort of in a bracket. I'm not just subtracting the c and adding the p. I'm subtracting the whole side. I'm actually going to get rid of those brackets because I think it can make it seem confusing. But I'm minusing the whole thing. And what happens? I do 2c minus c, which gives me c. I do p minus p, which gives me 0. And then I do 300 minus 250, which gives me 50. And this is known as elimination. So the first method was substitution. This is called elimination. Once I've got c equals to 50, I can substitute it back into either one of them, and I will again get p equals to 200. So I've solved simultaneous equations that are slightly trickier than the ones we looked at last lesson, because you have to rearrange first and set equal, or you have to use elimination. But I hope that makes sense, and we could do the same here. I'm going to do a few more examples though, and then I'll come back and refer to this one. Okay, we're going to do two more questions, and we're going to do them in two different methods. So, first of all, I think I'm going to do elimination, because this is sort of the new idea for today. And it is actually a bit quicker for questions like this. And in general, actually, I think it'd be a bit quicker, but I think it can be a little bit, like there's a bit more going on sometimes. Okay, so in this case, right, I did an example. I'm going to backtrack. I did an example where I had a p here and I had a p here, and because they were both positive, I chose to subtract them. In this case, if I subtract them, then it's not going to get rid of them, because I've got a 3b here plus, but then I've got a minus 3b. So if I chose to subtract them, which I could do, then I'd get a minus 6a is minus 5a. Then I do 3b minus minus 3b is plus 6b, and this would equal minus 6. And that does not help, actually. I've not got rid of one of the variables, one of the unknowns. So I don't want to actually do that. So basically, I don't always just want to subtract them. Okay, that's what I'm getting at here. Because the signs are different, actually in this particular case, I want to add them. So if I add them, I'm adding this left-hand side to this left-hand side, and this right-hand side to this right-hand side. This time it's like I've got my set of scales, and I'm like moving. I've got this here and I've got this here, and I'm like moving this over here. And to keep it balanced, I'm also going to need to move my 250. Now in this particular example, that doesn't help because I don't get rid of one of them. But in this second one, it does because of the negative. So if I add them together, let's go for it. I get 7a. These cancel. and then I'm just left with 18 plus 24, which is 42. So I've very quickly got a nice simple answer. And then a is going to be 42 divided by 7, it's going to be 6, and I can substitute back in. This looks like the easiest one to substitute back into. So it's going to be 6 plus 3b equals 18. Okay, all I've done is replace this a by 6 because that's what it is. I can then get 3b equals 12 and b equals 4, and I've solved the equation. A equals 6, b equals 4. Actually, this still has graphical solutions where like the two lines would cross in one place. Don't forget about that. Okay, we're going to talk about the second method now, and again, I don't want it to make it more confusing. I just want you to really have an understanding of the different ways you can solve these equations. The second method, we are going to make 3b the subject of both. Okay, because if I can do that, I can set the equations equal. So I'm first of all going to write the first equation as 3b equals 18 minus a. I've just subtracted a from both sides of this one. For the second one, I've got a little bit of prep work to do. So I've got 6a equals 24 plus 3b. That's step one. I've added 3b to both sides. And then to get 3b, I'm going to have to minus 24 from both sides. Okay, but now I've got two equations with 3b on one of the sides by itself. So what can I do? I can set, just like we did before with y's, okay, I can set these two things equal to one another because they are both equal to 3b. Therefore, 18 minus a equals 6a minus 24. What I would do now is I'd add a to both sides. 18 equals 7a minus 24. I'd then add 24 to both sides. 42 equals 7a. And we are back where we were here, actually. I'd get a equals 6. I'd substitute back in. I'd get b equals 4. So, I guess if I'm summarizing this, I would say substitution is an amazing method where you can just rearrange and set two equations equal to one another. The downside is that it's going to be a bit more complicated. There's going to be rearranging going on, and then you're going to have to solve an equation, rearrange that. It's lots of rearranging basically, but it will get you the right answer. Elimination is it's a new idea that we've just stumbled across today. I've tried to talk about scales to compare, talk about it, to give a visual understanding. It is actually quicker, okay? If you can just spot that you've got a plus and a minus, so you can add them together, but you do have to spot that, okay? And if they're both positives, then you do what we did in the first one, you would minus them. If they happen to both be negatives, then again you would minus them, because you would do minus p minus minus p. Okay, so if I'm going to summarize this, I'd say if you've got plus and minus, you add, and if you've got minus, plus and plus, or minus and minus, then you would subtract. Okay, but this is only going to work if they have the same number here. So we couldn't just, these are not very good at the moment, these a and the 6a. So it only works if the coefficients, we call them, are equal, except whether one might be minus and one might be plus. Okay, really hoping you're still with me on this. So hopefully you can now look back at this question 10, and you might think, right, I'm either going to make 2y the subject of both equations and set it equal. That would be my substitution. Or I could just add these two equations because I've got a plus and a minus here. So hopefully your understanding has come along. We're going to do one more example where we're going to use both methods. And I put this in for two reasons. First of all, some of you might think, oh, I can just look at this equation and I can try some numbers out and I can guess that a is 6 and b is 4. And it doesn't take that much. I don't have to show all this method. Well, guess what? You will be expected, first of all, to show your method. And secondly, I can come up with equations that don't have such easy answers, okay? The answers to these, I'll give you a little hint, they're both going to be decimals, and that's not something you would expect when you first look at it, since we're combining them to give nice whole numbers. But yeah, so that's point number one. And point number 2 is that it's not always the thing here, the second unknown, that where the coefficients are going to be equal. I had it on the first 2 examples, but don't be thinking, oh, it's got to be that one, it's got to be that one. Okay, here I've made the 7 C's equal to one another. So, method 1, elimination. Okay, we are going to notice that we've got a 7C here and a 7C here. They are both positive. So if we take on board what I said above, I said if both of them are positive, we're going to subtract the equations. 7C plus 8B equals 40. Now, a little hint again. You can decide which way around you subtract. If I subtract them around this way, then I'm going to get a minus here and a minus here. So what I'm actually going to do is I'm going to write them the other way around. There's nothing wrong with doing that, and it's going to speed things up in the long run. So I'm going to minus the left-hand sides, and I'm going to minus the right-hand side. So 7C minus 7C is 0. 8D minus 3D is 5D. And then 40 minus 29 is 11. And what I get is D equals 11 over 5, which is 2.2. Okay, I'm then going to substitute it back in. I think I'll substitute back into this one here. So I'm going to get 7C plus 3 times 2.2, which is 6.6, equals 29. Do you know what? I'm probably going to want my calculator for this. We could try and do it in our heads, but this is not really meant to be testing on non-calculator skills. And what I get is C equals to 3.2. If I want to be extra sure, I could check it. I could put it back into here and check I got 40. I do. I will get that. Okay, so you have to trust me on that one. So we're done. Very quick once you've understood this method. The second method, substitution, that we've been talking about last lesson and building on this lesson, okay, is I'm going to make 7C the subject of both equations. 7C equals 29 minus 3D. 7C equals 40 minus 8D. I can now set them equal. 29 minus 3D must equal 40 minus 8D. Okay, I can set them equal because these are the same thing. That's what I'm trying to solve, these simultaneous equations. I would then add on 8. Why do I add on 8D? Because then it's going to become nice and positive over here. Okay, if I add on 3D, I'm still going to have a minus 5D. So that's just a little tip. 29 plus 5D equals 40. 5D equals 11. And I'm back with more steps to where I was there. So I'm not, the finishing steps would be the same. So what I want you to do is, well, hopefully you've made some notes on this. I've spoken about 2 methods, both worth knowing about, okay? Elimination does make visual sense, I hope, when you think about sets of scales. Substitution does as well, I hope. It's the idea about the graphs crossing each other, and also just the fact that, of course, if we're finding a value of A, if we've got 6A and 6A or whatever, we can, or 3, I think, what have I done here? I can set them equal. I can set my 3B's equal here, okay? So when you practice questions, I would like you to try, not necessarily both methods for every question, but you could do that, but otherwise I want you to just change which one you use. Like I'm going to give you some questions, so use elimination for some of them, use substitution for some of them, get a really good feel for this. And guess what? If you forget one of the methods when you're then later on doing it, you can revert to the other one, okay? Because my opinion is that this is a bit easier to remember, but a bit more fiddly and technical. Okay, this is quicker, more efficient, and this would be what I would use for these equations, because I know that I'm going to get the answer quicker, and I'm not going to forget whether to add or subtract and so forth. But you've got to, it's a bit more, it's a bit more fiddly. That's the downside, and you've got to become confident with it. Okay, so try both methods, because there might be scenarios where this one actually just helps out a bit more. Okay, and we're going to continue with using both of these next lesson when we look at a different sort of type of simultaneous equation. Anyway, I've spoken for a while. I hope this all makes sense. Get on with some questions. Good luck.